Welcome everyone to Limitless Potential Technologies, the channel and series in which we are releasing a new clean form of energy production technology from here in my garage in Kelowna, British Columbia, Canada. We're doing this without fear or greed. We're not patenting anything. This is open sourced technology for the people. If you're interested in clean energy production, new technology, tinkering, building, manifesting, dreaming big, you're in the right spot. That's what we're doing here. And I'm going to bring you along for every step of the process, so stay tuned. We got a really good video for you today. We're going to be looking at this generator, our new form of energy production. We're going to show it running. We're going to be talking about coils, coil design, winding coils, losses within the system. We're going to show you a little bit of the precursor to this, the Bedini motor. We've upgraded that, so let's get into it. The last time that I left off in the previous video, we were having issues with this timing sensor, this optic sensor. So this optic sensor is what allows us to trigger the electronics in which we send electricity from one battery bank into this coil. When you send electricity through a wire, it causes a magnetic field outside of the wire. When you coil wire together into a coil such as this, and you put electricity through it, it becomes an electromagnet. When these switches put electricity into this coil, it produces a magnetic field around it. The way this one is situated and the way the amperage flows through it, this is creating a south pole on this face of the magnet, which is then attracting these north poles on the rotor. So we have permanent magnets facing out, or the north pole facing outward on this rotor, and they are being attracted to this pulse of electricity, which causes a magnetic field, a south pole to develop there, and then this induces motion into the rotor. You can see this optic sensor is firing when it's red. That little light indicates that it's firing. So these slots within this wheel, when there's a slot, it turns on the optic sensor, triggers the system, electricity flows into the coil. When the magnetic field collapses, there's energy that we can capture, and that's what we're doing with this battery bank. So we're recycling the energy and doing work with it at the same time. Now we hypothesize that we're going to get excess energy from this system because of the high voltage that we're collecting from that collapsing magnetic field. We've talked about this before. It's called flyback voltage. We'll get into that in a second. But we're hypothesizing that these high voltage spikes, when we slam the electrons into this charged battery bank, the internal chemistry within the batteries have ions. These electrons move faster than the slow moving ions, and it creates an imbalance in the battery, a dipole, positive and negative charge. Just like a magnet's a dipole, there's a dipole being created in these batteries. We then say this imbalance needs to be corrected by nature. The vacuum, the ether is going to correct the imbalance. It allows excess energy to flow into both the ions and the electrons, raising their energy. So we're saying that there's extra energy coming into the system because of this high-speed switching, this capturing of the back EMF, or this flyback voltage. We'll leave it at that for now, but that's our hypothesis. We have two hypotheses. We're hypothesizing two things on this channel. One being this energy collection system. We can build it. We can show that there is excess energy coming from the environment. And two, that you can change your reality with your thoughts. You can manifest, you can dream big, and you can build physical things and change the external reality around you just by the way you think and the way you act. That's what we're about on this channel. We're about acting, changing things within ourselves, and manifesting and creating and changing the external world, or allowing the external world to change around us because of that. So those are our two things that we're testing on this channel in this current build. One being this machine, and two being ourselves and our reality around us. And so far it's on the right track, let's just say that. So before we were having issues with this optic sensor blowing up, basically there was feedback. You can have energy flowing between wires, even if both of those wires are not initially carrying energy. That's what was happening in this system. The higher voltages from these switches was carrying over to the optic sensor circuit and blowing it up. Some of the leads, or some of the traces on the circuitry, were too close of proximity, and also we were sharing a power supply with the optic sensor and then the power supply for the rest of the electronics. Joe's fixed that. He's been grinding away, so have I. We've got 4 coils on this machine wound. I got a 5th coil up there. Even if it takes a couple weeks to put out a video, we're grinding away. You can be sure that we are relentless in our pursuit of this. We're not relaxing. We don't waste time. We're putting all of of our energy into this, and thank you so much for supporting it. Thank you to all the donors. Thank you to everyone. You made this possible. This reality that we're creating is possible because of you and us working together. So what have we done to fix this? Well, we put the optic sensor on a separate power supply, and we also we used some shielding on the optic sensor wires. The main thing though is that we put it on a separate power supply. We were planning on just using a little battery pack, something that you would use to charge your cell phone or your laptop on vacation. We were going to use this to power the optic sensor. Unfortunately, I tried to use that yesterday and it only works with a constant load. This optic sensor, as you can see, is not constant. It is intermittent depending on whether it's on or off. So that didn't work. Now we've got it on a separate power supply. Those guys from China, they gave us some free tools and they've continued to support us. So shout out to Finsri. So we're gonna put on some safety glasses. I'll show you why that's important. Bare minimum safety glasses. I was doing a video right before this and I had a trace blow off and scare me. I'll show you the footage in there for that. Let's just give it an initial kick. Whoa. This is the power supply. We've got 5 volts going to our optic sensor, completely external from the rest of the circuitry. And we're going to make sure there's only 2 coils on initially. We will engage our main circuitry. You can see the lights light up. So now we have power going to the main circuitry, but no signal from the optic sensor. So let's give this an initial push. You can see the optic sensor is firing. And we have electricity flowing into these wires, into the coil, causing the motion of the rotor. We're gonna let this guy spool up. I'm gonna turn on 4 coils total. So we have 4 coils running. Let's let this thing spool up. We'll take some measurements. We'll get into the good stuff. In the meantime, let's talk a little bit about some of the losses that we're overcoming and how we're getting around these losses that are a big problem in all of conventional electricity. So since Nikola Tesla created the first AC motor and they did away with him and others had to figure out what was going on and why there was so much heat being generated within them, losses and this balance between input energy and the losses within the system and how efficient you can make your motors. That's just been from the dawn of electricity and electromagnetism. That's what's been going on. Lenz's law was written in the 1800s. Let's go back to our river analogy. So in the previous video, we talked about electricity flow within a conductor being a river, a flow, and within this river, there's the electron flow, that's the electricity. Outside of the river, there's a secondary river. So there's a river within a river. The secondary river is a flow of magnetism. So we've got magnetism and electricity, or dielectric and magnetic. Those are the 2 components of electricity. You have to have both. Lenz's law states that when you induce a change in a magnetic field and it induces a flow within a conductor, there's a pushback, an opposite push to that direction. If we're inducing a flow this way, there's going to be a backflow counteracting that force. That's what back EMF is, okay? It's that backflow of energy counteracting your initial flow of energy. Anytime you change a magnetic field in the conductor, it's going to have that back pressure, that backflow. All modern machinery, for the most part, deals with this back EMF, and in the sense, it turns it into heat. It wastes it, okay? It does not recycle it, it wastes it. Lenz's law we need to deal with, right? That's something that wastes energy within the system. And there's eddy currents. So in this river flowing, when it's going through a conductor, there's little eddy currents. Anytime you take a magnetic field and you put it into a material, there's eddy currents. These eddy currents are circular flows of energy. They're basically amperage, and they convert and waste the magnetic potential. They turn it into heat. So there's a wasting of energy in eddy currents, and the eddy currents are dependent upon what material you're dealing with. So for example, in a traditional motor, when you have a core, they usually have iron or some kind of core material in there to concentrate the magnetic flux, right? So normally there's magnetic flux out, say here, but if you use a core, you can take it from the air and you can concentrate it and direct it, which is beneficial when you're trying to produce a motive force or you're trying to generate power. It's beneficial to concentrate that magnetic flux. But again, it comes at a cost. The core material you're using produces eddy currents. You get, let's just call it like a poor core material has larger boulders in there, which will produce bigger vortexes or bigger vortices, bigger eddy currents, more losses, more heat. a better core material would be something with smaller boulders, so smaller eddy currents are produced. This is why in traditional motors and generators, they laminate the core material, they layer it so it's not a continuous chunk of iron or steel. It allows less eddy currents to form, less wasted energy. It's just a high level of what's going on. In our cores, the way we're getting around this, we don't use any material in the center. It's an air core coil. So again, that comes at a cost. We're not as efficient in the sense that we can't concentrate the magnetic flux, but because the purpose of this generator is not to produce motion, it's a byproduct, it's secondary. It's a nice effect, but the primary purpose of these coils are to induce and collapse the magnetic field as quickly as possible. So we're getting around those eddy currents with the core material that we're choosing to use, which is air. Now we are going to start adding generator coils around the outside of this rotor as well to produce energy, produce conventional electricity. In these generator coils, you can see we've left this side open, and that's because we do plan to concentrate the flux with a core, an iron core. We want to still keep the eddy currents down as low as possible. In order to keep the eddy currents at a minimal, inside of our core, we're going to use small boulders. We want to keep small individual pieces of iron, and that'll allow us to concentrate the flux, but we don't want them touching. We just want tiny little boulders so there's smaller currents, less eddy currents, less losses. We're going to do that with these soft steel BBs, which are for reloading shotgun shells. We got this idea from Paul Babcock. We're going to coat these with a clear acrylic, and that's because we don't want the steel touching itself. We want individual tiny little boulders within that river, so less eddy currents. So that's what we're going to do. I know that the Mueller motor, Bill Mueller, he was using, it was either like magnetite or iron filings, basically black sand that he was finding in the river. He did the same thing. He put the epoxy in with the black sand. And again, it's all the same idea. Small, tiny little pieces, little flecks of iron or the core material isolated from one another. So it's just little boulders, small eddy currents, less losses. There's also the losses within the actual material itself. So not just the size of the pieces of material in the core, but the material itself causes something, hysteresis. So hysteresis is basically a time delay, the history between the input event and the output event. Hysteresis can apply to all sorts of energy conversion. It's not just magnetic. But what it's talking about here in our sense, or in our build, what we're using it for is to describe the speed at which the magnetic field is induced is not the same speed at which it demagnetizes. Iron is soft. It doesn't have a bunch of carbon in it. Steel has carbon. The higher the carbon content, the bigger the hysteresis, or the slower the magnetic field demagnetizes. We don't want that. Again, the energy that we're trying to put into this battery bank, we want it to be as quick as possible. We want a fast collapse of that magnetic field. So that's why we're using air cores. It negates this hysteresis as much as possible. It negates Lenz's laws and eddy currents as much as possible. Again, Lenz's law and eddy currents are not so much applicable to that flyback, but the hysteresis is very applicable. It slows down that river. We want to be able to induce that river and get rid of the river as quickly as possible. In and out, okay? So that's what we're doing for coil material. We got new gen coils coming. We're going to wind them. I think we're going to probably wind them maybe half full, so they're only like 2 inches thick of wire, and that's because when the magnet passes by, the majority of the flux from the magnet is, within that 2-inch vicinity. We probably don't need 3.5 inches of wire. We're going to see the difference. I'll wind one with 3 inches of wire. I think we're going to start with 38 gauge. We'll just do traditional winding. I'm not twisting a bunch of wires together for those, thank God. And we're going to use soft iron cores and epoxy sprayed with the clear acrylic, and we'll also try some magnetite or iron filings. We'll try a couple different things and see how efficient of generator coils we can get. These gen coils are going to produce conventional E&M energy. It's got nothing to do with the other system. So there's one side of the system powering it. It's conventional to the point where it goes in the battery. After that, we're talking about non-conventional electricity. We've been through this in the previous videos. When the energy goes into the battery, that high voltage spike, the dipole, that's non-conventional. Everything else I'm talking about is conventional. So the recycling of the energy, the cores, the generator mode, all conventional. Anyways, let's go check out this motor and see where we're at with this. We've had our motor spooling up for a little while here. We're getting close to 200 RPM, 196, somewhere around 200. Now, I ran this the other day, and it was up to 250 RPM with the exact same setup. I think those Chinese bearings are not the greatest. These are the Chinese bearings. They do spin very freely. They're ceramic, but they're not lubricated. They're dry, so I don't think they're as durable. These are the new bearings we've got from Optic out of the US. These particular ones here are a hybrid construction, so they're very high quality Japanese steel. They have a rating. It's called APEG. APEG rating is like the precision and the tolerances. This one is an APEG 7, and then these are the full hybrid, or sorry, the full ceramics, and they have an APEG rating of 5. So we've got full ceramics, APEG 5, and hybrid ceramics, APEG 7. So I'm torn on which ones to go with. I'll probably end up trying the full ceramics. Both of them are packed with grease. They're much higher quality. They were like $200 per bearing versus the $3 per bearing from the Chinese ones. Shout out to China though, we love your stuff. I've got $5,000 worth of wire coming tomorrow, all from China. All the mag wire is amazing. You know, it's hit and miss. You got to try stuff out, but bang for your buck from China, amazing. So the cost of this project, I'm going to put it in the description. I've got an Excel sheet showing all of the costs that have gone into this build, where your money's going, how much we've spent, what it's been spent on. Check it out. I'll put it in the link. I want to be fully accountable. Thank you so much for the donations. If you can donate, the crowdfund's still up. All of your contributions are going directly to the science. Our time is completely donated. We're putting in 20, 30 hours a week sometimes, and it's all towards the scientific endeavor. Again, we're relentless. We will never stop. Your money's going to good use, and you can see where it's going with that link. So check it out. Now, should we take some measurements? Just preliminary measurements? Yeah, of course we should. Let's take a look at the battery voltages here first. This is going to show negative, but we're at 25.53, and the input, we're at 24.93. So that's our voltages, and then I've got a clamp DC multimeter, or clamp DC amp meter here. It's definitely not 100% accurate, but it shows 1.17, just call it 1.2 or something, right? That was the in battery, the amount of energy going into the system. And we're at 0.8 on the charge battery and 1.18, 1.17 on the input, okay? So 1.17 on the input at 24.9 volts, what did they say? 0.84, 0.85 at 25.54 volts. It's not 100% efficient. I'm not claiming anything. You can do the wattage conversions on that. It's like 60%, 60 to 70% electrically efficient. But then there's a certain amount of energy that's required to keep this 70-pound rotor spinning. As far as I can calculate, it's between 5 and 15 watts. It's a pretty smooth surface. There's some air drag on the surface I can feel just because there's grooves for the magnets. It's not pure laminar flow. Anyways, we're just showing that, you know, we've got energy coming out, energy going in. This is all conventional E&M. And again, our hypothesis is that there's extra energy coming into these battery banks. And this is just at 24 volts with 4 coils. This is like the very preliminary minimal test. But I can say that I've been doing measurements on the other Bedini motor here, which I've actually upgraded the electronics. I've got this thing working better. I put silicon carbide diodes on this guy, and I'm just doing some tests, which I'm going to put out in another video for you and show you all of the measurements on this traditional Bedini motor and the efficiencies of it. Took us a while to redo these electronics. Like I say, we got silicon carbide on there now, but overall, this system is much more electrically efficient than the Bedini motor is. So throughout history, you guys, remember that humanity's always known certain things are possible, and this is why I'm getting into this other hypothesis that our mindset and we ourselves, our internal, creates this reality. you know, they tell us, we go off what modern science is telling us. Quantum physics tells us that electrons and atoms are just, they're not even physical, right? They just manifest from energy. They come from energy. So we're made of these, we're energy. Everything around us, all of this physical reality is energy-based, which is crazy, right? That's why the metaphysics makes sense. Non-physical affecting the physical reality. It's like, well, that's because everything's non-physical when you get down to the base layer. And throughout history, there's been examples where humanity knows something is possible, and there's a consensus. There's just this underlying consensus and knowledge that something is possible. For example, heavier than air flight, right? Leonardo da Vinci was making designs of heavier than air flight long before it took place. There's tons of examples of this throughout human history. We know something is possible. There's a consensus. We can feel it, and then we manifest it and build it, and it becomes a reality down the road. That's exactly what's happening here. Nikola Tesla knew that we could tap into the ambient energy of the vacuum, power our machinery, integrate with nature and the framework within it. We can feel that that is possible. We know that this is coming. Most likely has been done and is being done right now, but we're going to prove it here. That's what we're after. Don't ever think that something's impossible. Don't let people tell you what's impossible. Go after it, build it, test it yourself, do real science. That's what real science is about. We're going to build more coils. We're going to step up all of the coils, the voltages. We're going to take our gen coils. We're going to start placing generator coils around the outside, produce some conventional electricity. Everything's a work in progress. We've got a new timing system coming. We're not going to keep using the optic sensors solely. We're going to maintain the optic sensors for like a backup, just that initial trigger. But Joe's got a nice encoder system built, which is basically a Hall effect sensor, an advanced Hall effect sensor. We're going to be able to pulse width modulate the machine from the phone, advance and retard the timing. Everything's going to be amazing. So new timing, obviously the data logging and the measurements of the systems. We've got the battery flip-flop coming. We need to be able to switch back and forth, use the energy within that battery for the run battery and vice versa. Maybe in the future we'll need to do 3 battery banks. I don't know. There's a lot to figure out, but we're making progress. It's running. The optic sensor's not blowing up. Fabulous. Thank you all for watching. Stay tuned. It's going to get real interesting here over the next few months. And again, this is real science. Believe in the limitless potential in all of us, all of you, and this world. Let's create together. I love you all. Thank you so much. This is amazing. Talk to you soon.